I welcome you all for Neetu Chemistry channel. Today we are going to see about the topic polymer chemistry. So you all familiar about the polymer nowadays. From morning to night, everyone is using only polymer materials. All plastics and other materials, whatever you are using is made up of polymer only. So if you need to know the difference between a polymer and organic molecule, whenever you take organic molecule, for example, benzene, if you take dissolve it in water, you will be getting a clear solution of benzene. After some time, you will be getting some settling down at the bottom. After the saturated solution, always whatever compound you take, it will settle down at the bottom. But when you dissolve the polymer, on heating and dissolving, you will be getting only a viscous mass of polymer, a thick molecule like jelly like molecule you will be getting in the polymer. So from that you can see the difference between an organic molecule and a polymer. Polymer will be having high density, high viscous strength. The strength of the polymer will be very higher. The thickness, the density of the polymer will be very high compared to the organic molecule. So from the name itself we can say poly means many and mer means unit. So when many units combine together to form a big giant molecule with a chain like structure, you call it as a polymer. So this polymer example, there are different examples: polyethylene, polyvinyl chloride, polytetrafluoroethylene, polypropylene, like the different examples you are having for polymer. So if you consider polyethylene, your plastic covers. So it is made up of ethylene when combined together to form a long chain of polyethylene. So it is prepared under addition polymerization. Like that polyvinyl chloride, PVC, pipes and all you are having, right? So that PVC is made up of vinyl chloride polymer. It should condensing together to give a polymer polyvinyl chloride. In ancient days, we had used natural polymers like we are getting wood from rubber industry, and then cotton is obtained from for manufacture of wool, then leather which is used from silk. So like the different natural polymers are there before, but nowadays we are having many synthetic polymers used in day to day life. So the synthetic polymers have different molecular structure. According to that, the nature of the polymer will be changing. So if you consider linear polymer, it will be a straight linear structure, and then branched means you will be having some side chains. Cross linked means each chain will be joined together with a cross link network, and then it is a network polymer at last you have. So all these polymers, increasing strength you have from linear to network structure. That strength and the rigidity, the toughness of the polymer, everything will be increasing from when you move from right to left. Left to right, sorry. Linear, branch, cross-link, network. In this order, if you are moving, the increasing strength of the polymer can be obtained. So before we had used mostly plastics and rubbers, right? So plastics are nothing but it will be having only a particular surface temperature it can withstand. Then it will be breaking or demodifying its shape. In rubber, you will be having some elastic nature. Nowadays, the polymers are classified as thermoplastics and thermosetting plastics. So if you consider thermoplastic polymers, it will be softening once, and then when you heat it, remold it again, you can get it into different shape, and vice versa, you can do it again and again. So these are obtained only from linear and branched polymer networks. For example, polyethylene, polystyrene and all. If you take polysetting polymer, thermosetting polymers, it is permanently hard. Once you get the polymer, you can't change the shape. It will be very hard and you can't make it into different shapes by heating and molding it again. So these are all obtained from a high tensile strength network polymers. That is why we can't change the structure. It resists the motion. Examples are epoxides, phenolic resins, polyester resins. These are all examples for thermosetting polymers. Now we can see what is the mechanism, how polymer is prepared by different mechanism. First we can take addition polymerization. So when polymers undergo coupling of the monomers without any elimination of small bonds, it will undergo only the usage of multiple bonds. The bond will be shifting. That will take place in addition polymerization. There won't be any elimination of the groups. We can take example of polyethylene, which is obtained by ethylene molecule, and then styrene, which is giving polystyrene. Polyvinyl chloride is obtained by this mechanism. So these are all the different mechanisms, different molecules obtained by addition polymerization mechanism. So if you take polyethylene, we are using it as packaging bottles and all. Polypropylene is used mainly for kitchen base. And then polyvinyl chloride, PVC pipes and all we are using it, as well as for packaging purpose we are using PVC. Next is styrene. When it undergoes polymerization, you will be getting polystyrene. So this is the example for addition polymerization. So after seeing example and definition, we will move on to the mechanism of addition. So next, if you take condensation polymerization second type, this polymer formed by elimination of small groups. For example, water, ammonia, methanol, like that. Small groups can be eliminated by condensation polymerization. So that it will also forming a polymer, but elimination of groups will take place. For example, you consider nylon 6,6. It is obtained 5 addition of hexamethylene diamine. Hexamethylene means 6 methylene groups and 2 amine groups at the 2 corners, that is hexamethylene diamine, with adipic acid group we are having. So these two, when it condenses, we will be getting elimination of water, H2O will take place. So with the elimination of water, you will be getting nylon 6,6 formation. So why we say nylon 6,6 means in adipic acid also we are having 6 carbons. In hexamethylene diamine also there are 6 carbons. So when 6 carbons, it will be combining together to form a molecule. That is why we call it as nylon 6,6. Next we are seeing what is the synthesis of polymer. What is the type you had seen. Now how it is synthesized by different mechanism. So we are having 3 different methods of preparing polymers: step growth polymerization, addition polymerization, insertion polymerization. So first today we can see what is meant by step growth polymerization. So step growth polymers, it is also called as condensation polymers. It is made by combining 2 molecules by removing a small group or small molecules. For example, water, methanol and all. So here we are taking example of dimethyl terephthalate. When it is treated with 1,2-ethane diol, always polymer will take place under particular pressure and temperature only. So you will be getting polyethylene terephthalate with the elimination of methanol group. So this is commercially called as Decron. So this mechanism is called as step growth polymerization. So 2 different polymers will be condensing with the elimination of small group. So this, and then types of addition polymerization itself if you take, we are having different types like free radical, cationic, anionic polymerization types and all possible. So now we can see about free radical polymerization. So when many low molecular weight alkenes undergoes polymerization reactions with the help of indicators only. So indicator is nothing but free radical. So free radical, how we are getting now, it is obtained by this mechanism takes place by 3 steps: initiation, propagation, termination. So initiation we will be getting free radical. Propagation the living chain of the polymer will be growing. In termination, we will stop the chain of the polymer. So initiation step, we are having monomer unit which will split into 2. For example, ethylene if you have, it will split into 2 as CH2 dot. That radical you will be getting, that R dot will be, the radical whatever we are having, it will combine with the ethylene molecule to give another radical which is called as initiator. So this RR we are writing, no, it could be anything depending on the, for example, peroxide group, it may be CH3COO. COCH3, like that, some peroxide group or something which can split into 2 and produce as a free radical, that you call it as an initiator. In the presence of heat and pressure, you will be getting the initiator. So that initiator will be having electron in it, single electron will be present. So that electron will be ready to react with the monomer unit. So R dot is the initiator which is ready to react with the monomer ethylene. So when this reacts, you will be getting another initiator at the corner of ethylene carbon. So next step is propagation. So that initiator will react with another molecule of ethylene to give the initiation step with the chain molecule at the corner. Next, another molecule will be ready to react. When there is an initiator, a lone pair of electron at the corner, next monomer will be ready to react again and again. So each and every monomer will be adding in a chain. One by one it will come and add with the living polymer or growing polymer. So when it acts, it forms a long chain of polymer molecule. After that, we are supposed to stop the chain. So for that we are having termination step. In termination step, what happens now? You will be having a propagation step polymer. Two polymer chains we can take in one mechanism. It will couple together to give a product. Both the radicals will be joining together to give a dead polymer. So this process is called as coupling reaction. One more second type which is called as disproportionation. What happens now? Here you will be having two chains of propagation step polymer. So one chain will be forming a saturated molecule. Another chain will be forming a unsaturated molecule by eliminating the radical. So this molecule will undergo hydrogen transfer from one chain to other chain. This the process is called as disproportionation, so that both the chains can be stopped, but the chain length of the polymer will be less compared to the coupling step. So coupling will be easier, and you will be getting a bigger long chain in coupling process compared to disproportionation process. Next, the second type of polymerization is ionic polymerization. So ionic polymerization, you are having cationic polymerization and anionic polymerization. So in next video we can see about ionic polymerization, what is the mechanism taking place in detail. Just ionic polymerization is nothing but you are having two types. As free radical polymerization, we have radical. Here ions will be undergoing the polymerization initiation step. So in cationic you will be having electron donating group always. In anionic, electron withdrawing group will be present as a R group. So which will be acting as a chain initiation process. So this chain initiation process will further propagate with the propagation and termination steps. So those steps can be, I will be putting videos in the next class, and I will be explaining about it in detail. Thank you for watching my YouTube channel. Thank you very much.